Hello everyone, welcome back to my math channel. This is Mr. Mahmoud explaining Algebra 2, Chapter 6, Lesson number 8. And this is the second part of the lesson, Natural Logarithms. And we are going to focus on solving equations containing e and ln. Let's begin by this example. Solve 3e to the power of negative 2x plus 4 equals 10, round to the nearest 10,000ths. First of all, we need to separate e with its power. We need to get it alone so that we can deal with x in the power. So, this is the original equation, 3e to the power of negative 2x plus 4 equals 10. We can subtract 4 from both sides, or you can simply get 4 to the other side in negative. So, 3e to the negative 2x equals 6. We can divide by 3 for both sides, so e to the negative 2x equals 2. We can take ln for both sides because we know that ln will cancel the e because they are inverse functions. So now negative 2x equals ln 2, and we can divide by negative 2 for both sides, so x equals ln 2 over negative 2, and you can use your calculator to find the value of x. It will be approximately negative 0.3466, and this is the solution of the equation. Now this is your turn to solve. What is the solution of the equation 2e to the negative 2x plus 5 equals 15? Pause the video and try to choose, and you will find it A. Now let me show you how. This is the original equation. I take 5 to the other side in negative, so it will be 2e to the negative 2x equals 15 minus 5. So 2e to the negative 2x equals 10. Now I will divide by 2 for both sides. So e to the negative 2x equals 5. Now I will take ln for both sides, so this will be ln e to the negative 2x equals ln 5. Ln will cancel the e because they are inverse functions, so negative 2x equals ln 5. Let's divide by negative 2 for both sides, so x equals ln 5 over negative 2, and if you use your calculator you will find it approximately negative 0.8047. So A is an accurate answer. Now example 5a, solve 2 ln 5x equals 6, round to the nearest 10,000. So first we need to separate the ln 5x. We must get it alone, and this is very easy. This is the original equation. We can divide by 2 for both sides. Divide 2 divided 2 will give you ln 5x equals 3. Now since we succeeded to get the ln alone, we can transform now into exponential. So it will be, let's take base e for both, so e to the ln 5x equals e to the 3. Now e and ln will vanish each other, so 5x equals e to the power of 3. Let's divide by 5, divide by 5, so x equals e to the power of 3 over 5, and we can leave it as an exact answer, or if the approximated answer is required, we can use calculator. X approximately equal 4.0171. This is the final answer. Solving inequalities. Solve the inequality ln 3x plus 1 to the power of 2 is greater than 8. and round to the nearest 10,000. So this is the original inequality. Let's take e to the power for both, means base e for both sides. E will cancel the len, so this will be 3x plus 1 power 2 is greater than e power 4 all to the power of 2, because e to the power of 8 can be expressed as e to the power of 4 all to the power of 2. Now we can cancel power 2 with power 2, so 3x plus 1 is greater than e to the power of 4. Take positive 1 to the other side, so 3x bigger than e to the 4 minus 1. Now let's divide by 3, so x bigger than e to the power of 4 minus 1 over 3. Or we can say x greater than 17.8661. So the final answer is x such that x is greater than 17.8661. Now this is your turn to solve. Pause the video and try to choose, and you will find it C. Let me show you how. This is 3 ln 6x equals 12. Let's divide by 3 for both sides. This will be ln 6x equals 4. Now let's use e to the power, so e to the ln 6x equals e to the 4. E and ln will vanish each other, so 6x equals e to the 4. Divide by 6 for both sides, so x equals e to the power of 4 over 6. And we can use calculator to find this one, and you will find it 9.0997. So C is the accurate answer. Also try to solve this one. Pause the video and try to choose the accurate answer, and you will find it A. Let me show you how. The original inequality is ln 4x minus 2 is greater than 7. So ln is already alone, so no number in front of ln, no added, no subtracted number, so we go directly for the step e to the power of ln 4x minus 2 is bigger than e to the power of 7. E will cancel the ln, so 4x minus 2 is greater than e to the power of 7. Take negative 2 to the other side, so 4x is greater than e power 7 plus 2. Now let's divide by 4 for both sides, so x is greater than e power 7 plus 2 over 4. Use your calculator and you will find out that x is greater than 274.66. So A is an accurate answer. Now continuously compounded interest. Calculate continuously compound interest using the following formula. This is one of the important application of the E and ln. A equals P e to the power of RT, where A is the amount in the account, means your final balance after T years, and P is the principal, the original amount invested, and R is the annual interest rate. Let's take an example. Suppose you deposited $700 into an account paying 3% annual interest compounded continuously. What is the balance after 8 years? So you deposit $700 means this is the P, the original amount, into an account paying 3%, this is the R, the rate, annual interest compounded continuously. So we'll use our rule. What is the balance? The balance, which is A, equals what? After 8 years, this is the T. So now let's use the rule A equals P times e to the power of RT. So substitute P as 700 and R as 0.03 because we transform the percent into decimal. Just type 3 over 100 and it will give you 0.03 multiplied by T, which is 8. Now we can use calculator for this one and you can find it as 889.87. So after 8 years it will be $889.87. Now suppose you deposit the same amount 700 into an account paying 3% annual interest compounded continuously. How long will it take? Means I'm asking about the time. How long will it take for the balance in your account to reach at least means greater than or equal at least $1,200. So the balance is at least $1,200. So we need the A to be more than or equal, greater than or equal 1,200. This is the A. We know that the A, it was the rule P times e to the power of RT. So the 700 e to the power of 0.03 times t should be bigger than or equal to 1,200. Now let's divide by 700 for both sides. This will give you e to the power of 0.03t greater than or equal to 12 over 7. Now we can take ln for both sides, so that ln will cancel the e, so it will give you 0.03t greater than or equal to ln 12 over 7. Now we can divide by this number to know that t should be greater than or equal to ln 12 over 7 all over 0.03, and you will find it 17.97. So t should be greater than or equal to 17.97. So it will take about 18 years after the balance to reach at least $1,200. Suppose you deposited $700 into an account paying 3% annual interest compounded continuously. How much would have to be deposited? We are asking for the P now, the original amount, in order to reach a balance of 1,500. This is the A given after 12 years. So we begin by the same rule, A equals PE to the power of RT, and in the place of A we will substitute 1,500 equals P times e to the power of 0.03 multiplied by 12. This is the unknown, the original amount deposited. So we can divide both sides by e to the power of 0.36 because we know that 0.03 multiplied by 12 will give you 0.36, so that we can get P alone. Now using calculator we will discover that P is about $1,046.51. Means you need to deposit $1,046.51 for your balance to be 1,500. This is your turn to solve. Pause the video and try to choose, and you will find the accurate answer is C. Let me show you how. Suppose you deposit $700 into an account paying 6% annual interest compounded continuously. What is the balance after 7 years? Let's summarize the information. We have here P equals 700. This is the original, and R equals 6%, which is 0.06, compounded continuously, so we'll use our rule. What is the balance after 7 years? Means T equals 7. Now we begin with the rule A equals P e to the RT. So this is the required A equals 700 times e to the power of 0.06 multiplied by 7, and we will use calculator to find out that it will be $1,065.37. So really C is the accurate choice. Another guided practice you need to solve, so pause the video and try to choose whether it's A, B, C or D, and you will find it C. Let's see how. Same information, the P is 700 and the R is 0.06 compounded continuously. How long? How long means we need the T. T equals what? How long will it take for the balance in your account to reach at least means we need A to be greater than or equal to 2,500. The same, we know the A is the rule, which is B e to the power of RT, so we substitute here with 700 times e to the power of 0.06t, and this should be greater than or equal to 2500. Let's divide both sides by 700. This will give you e to the power of 0.06t is greater than or equal to 25/7. Now let's take ln for both sides. We know that ln will cancel the e, so it will be 0.06t is greater than or equal to ln 25/7. Now let's divide both sides by 0.06. This will give you t should be greater than or equal to ln 25/7 all over 0.06, and use your calculator to find out that t should be greater than or equal to 21.22 years. So C is the accurate choice. Another problem. Suppose you deposited money into an account paying 3% annual interest compounded continuously. How much would have to be deposited in order to reach a balance of 1,950 after 10 years? So let's gather the information. We have the R equals 3% means 0.03. Compounded continuously, we know the rule. How much would have to be deposited? So the P, we need to know what is the P in order to reach a balance of, this is the A equals 1950. After 10 years, T is 10. It's a simple solving equation. You just need to remember the rule. A equals P times e to the power of RT. Substitute here. 1950 equals P is the unknown. E 0.03 multiplied by 10. So we can divide both sides by e to the power of 0.3, because we know that 10 times 0.03 will give you 0.3. So it will take the shape 1950 divided by e to the 0.3 equals the P. Use your calculator to find out that B equals, yes, the accurate choice will be D, $1,444.60. By this, my dear students, we come to the end of our lesson for today. Till we meet again, goodbye.